Hello, this lesson is about parabola. Um, we already covered cases where our equation was in the form of y equal to 2x plus 1. And we know that when we plot all the points which we find using this equation, and we connect them together, we will get a straight line. But what if rather than having a power of 1, because here in this equation, which was the equation of a line, the power of x is 1. So when you don't have any power, it means 1. What if the power was anything other than 1, like what we have here? Y equal to x squared. This is a different equation in nature to this, because the power of x here is 2. In this lesson, we are looking to see if we get all the points based on this equation and plot them, connecting them together, what will be the result we get, what type of shape or 2D line, whether it's straight or not, we will get. That is the question we will be looking at today. All right. If we plot those points using that equation, y equal to x squared, you know that the first step is to make a table of values. We're making table of values using this equation. You start giving values for x from say -3, then -2, -1, 0, 1, 2, 3, going up by 1. And then this is up to you. The values of x you're choosing is up to you. But then you find the corresponding values for y. So based on this rule, once you've chosen your x and you've got the equation given, the y is not up to you. You got to substitute for x here and find your y. All right, if my x is -3, then this rule tells me y is equal to x to the 2. So that means -3 squared. -3 squared means -3 times -3, negative times negative is positive, and 3 times 3 is 9. It gives me 9. Similarly, if I substitute -2 for x here, that's going to be y equal to -2 squared, and -2 squared is 4, so y becomes 4. And if you keep doing that, when x is -1, y is 1, x is 0, y is 0. When x is 1, you sub here and you get 1 for y. X is 2, y becomes 2 squared, 4. X is 3, y becomes 3 squared, which is 9. Now we completed the table of values and we can plot those points. Remember that this specifies a point, these two numbers together. X is -3, y is 9. This is another point. X is -2, y is 4, x is -1, y is 1, and so on. All right, let's plot these points now. We had -3 and 9 in the table above. So x was -3 and y was 9. So x -3 and I need to go up by 9. That gives me this point. Then when x was -2, y was 4. So I start with x -2 and I go up by 4. So that gives me that point. X was -1, y was 1. So I start from -1 on the x-axis and go up by 1. x0, y0, that is the origin. When x was 0, y was 0. That's another point. X was 1, y was 1, x was 2, y was 4, x was 3, y was 9. Now you got all these points, you connect them together, and as you can see, you're not having a straight line anymore, and this type of shape is called a parabola. And as you can see, this parabola has a minimum point here. That's the minimum point of the parabola, or sometimes we call them vertex. So vertex or minimum. All right, so that is a basic parabola. What if rather than having y equal to x squared, I had y equal to minus x squared? So that means I got to square x, whatever it is, and then put a minus in front to calculate my y. All right, let's make a table of values for this and see what we are going to get. When x is minus 3, again you choose your x values. Start from, for example, minus 3 and go up by 1, minus 3, minus 2, minus 1, and so on, up to 3. Alright, once you got that, now use your equation or your rule to find the y values. X is minus 3, so then y is minus, then minus 3 squared. Minus 3 squared is minus 3 times minus 3. That's 9. And I've got a negative in front of that. So it becomes minus 9. When I'm having x equal to minus 2, I put minus 2 for x and I square it. Minus 2 squared is 4. And I've got again a negative in front, makes it minus 4. And when I'm putting x minus 1, becomes minus 1 squared. Minus 1 squared is 1. But again, there is minus 1 in front, makes it minus 1. And so on. When it is 0, 0 squared is 0, and minus 0 is just 0. And we continue with the other ones as well. And as you can see, all y values now are negative. Again, this is 1 point, x minus 3, y minus 9. This is another point, x minus 2, y minus 4, and so on. Now we plot those points. If you do that, you have x minus 3, that's x-axis, this one. So minus 3 and y was minus 9. So I got to go down by 9. So that's my first point. The other point was x minus 2, y minus 4. That is minus 4. Then x was minus 1, y was minus 1. That's minus 1. X was 0, y was 0. You get that point, which is the origin. X 1, y minus 1. You get that point. X was 2. We had y minus 4. You get that point. And you get 3 for x, and y was minus 9. So that's minus 9. You connect all these points together, and again you get a parabola. This time around it is an upside down parabola, and it has a maximum now. Okay, it is an upside down parabola. So when you have y equal to minus x squared, you have an upside down parabola like that. Sometimes they call it a frowny face, but y equal to x squared is a smiley face. This was y equal to x squared. It made a smiley face, and y equal to minus x squared, which was that, makes a frowny face. All right. Now let's make a bit more changes to our equation to see what happens. Say rather than having y equal to x squared, now you have y equal to x squared plus 2. Y equal to x squared plus 2. Again, you choose your x values, starting from minus 3 going up by 1, and you use this rule to find your y values. So x is minus 3, you put minus 3 squared. Minus 3 squared is 9. plus 2 makes it 11. So x minus 3, y is 11. Then x is minus 2. So put minus 2 here, minus 2 squared is 4, plus 2 is 6. Then x is minus 1. Put minus 1 for x here, minus 1 squared is 1, plus 2 is 3. Then put 0, 0 squared is 0, plus 2 is 2. Put 1, 1 squared is 1, plus 2, 3, and keep going like that. So we want to see what this will be. So what we did here, we had the same parabola as before at the start, y equal to x squared. The only difference is we added 2 to x squared. And if you put these points together and connect them together, you get like minus 3, 11, minus 2 was 6, minus 1 was 3 if you go by the table, 0 was 2, 1 was 3, 2 was 6, and x3 was y11. So you get these points, these dots, and connect them together. Again, you have a parabola, which is like a smiley face. But before, your parabola had its minimum here, y equal to x squared. But now, it has shifted up by 2. So you shifted the whole parabola up by 2. And you can see it in your equation too. See? Plus 2. So that plus 2 that we put next to x squared made the parabola shift up by 2. Similarly, if you had an equation like y equal to x squared minus 1. In the previous one, we were adding something to x squared. Now we're subtracting something from x squared. So y equal to x squared minus 1. If you make a table of values for that and sketch it, the table of values will be like this. Minus 3, 8, minus 2, 3, minus 1, 0, and so on. Because like if you put minus 3, you get minus 3 squared, which is 9, minus 1, 8. If you put minus 2, it becomes minus 2 squared minus 1. Minus 3 squared is 4, minus 1 is 3. If you put minus 1 for x, minus 1 squared is 1. Take away 1 is 0. If you put 0 for x, 0 squared minus 1 is minus 1. So you get all these points, and you get these points, points with red dots I've shown. X was minus 3, y was 8, x was minus 2, y was 3, x was minus 1, y was 0, so we don't go up and down. X was 0, y was minus 1, and so on. So you connect all these points together. Again, you have the same parabola. The only thing is, the original parabola y equal to x squared was had its minimum here. Now the minimum has gone there. So your whole, and you can see it from, again, the equation. The equation is y equal to x squared minus 1. That's the equation. Y equal to x squared minus 1. So that means it is the same as y equal to x squared. Just shift it down, shift the whole thing down by 1. Thank you for your attention.